All right. Hello, everybody. This is Mike. That was my hand. And this is the 10 question quiz solutions video. This will be the first one in a sequence of videos. This should last a couple weeks of questions. But whenever I'm going to do different questions, I will load up a new video. So let's get started with the 10 question quiz problems for today, which is Wednesday, September 23rd. So first question, we got 721 plus 178. So again, this is day 2 questions of day 2 of 40 days. It's crazy that we only have 40 days of class, so this is the second one. And so we've got two 3-digit numbers here. So what do we actually have to do? Well, you might remember that when you have two numbers and you want to add them, you put them in these columns. So you put them in these columns, you put plus out here, you draw this line. This might be familiar for you from a while back. And we always start on the ones side. So we go 1 plus 8 is 9. Bingo. We go 2 plus 7 is 9. Bingo. We got 7 plus 1 is 8. 899 is the answer to this. We went from the ones up. Now, in future questions, if this goes over, then over 10, then we're going to carry that 1. Remember that? So if this column was larger than 10, we're going to carry that 1, leave the first digit there, and then carry the 10 over to that. And then you just add it through. So I won't go through that, but just reminding you, getting your brains warmed up with this first set of solution videos. Similarly, if I added another digit out here, then that would just carry through. There'd be a phantom 0 there, and that would be 1 plus 0 is just 1. Okay? So that is the answer to question number 1, and the original one was 899. So that's the question, or that's the answer that you want to get. So in the 10 question quizzes, you can mark your own work here. You can also re-practice. That's an ideal if you're struggling with a particular question. Or you can watch these videos and just go over them again and again until you get these skills. These are the basic skills that you're going to need moving forward, and that's why we're focusing on them first. So next up, question 2. We got 202 times 10. Okay, well, what's going on there? Times 10 is a special multiplication. That's the reason why I'm giving it to you in this first set. You don't have to memorize, right? Like 7 times 8 is 56. You got to memorize that. But on these, you don't have to. You can just figure it out. 10 means that you just add a 0. So the trick is you write out the first number again, and then you just add 1 0 afterwards. So it's almost like this 0 carries over into the number. That's the special trick when you're multiplying by 10. Also, just to put it out there, if we change this and we had 202 times 100, then those 2 zeros would carry down. And so we'd have 202 0 0, and that would be 20,200. So the answer here was 2020 is how we would say that, because this other one times 100, I was just telling you that, but the answer you're looking for is 2020. So that's question 2. That's multiplying things by tens. Question 3. Let's go through this. So this is a unit conversion. We got 2,000 meters. That's what that stands for, meter. Equals how many kilometers? This is a kilometer. So we're looking for how many of these meters make up however many kilometers. The thing that we really want to remember here is that there are 1,000 meters in 1 kilometer. That's just like a fact. You know, like you can measure your own height, and that's a fact. This is just a fact of life. This is how we've defined these things. 1,000 of these go into one of these. Now, if that's true, and again, a meter is about 1 step, just to give you a sense of direction and distance there. A kilometer takes about 3 to 5 minutes to run, because you're taking about 1,000 steps. So how many kilometers would we have gone if we've gone 2,000 meters? Well, that means you basically multiplied this side by 2, and then you multiplied this side by 2. So we have 2 kilometers equals 2,000 meters. So the answer there is 2. So again, mark yourself right or wrong, and then we'll go one piece at a time here. So that was question 3. 2 kilometers is the answer. Look for more complex things going through on that in the future, on future questions. Question 4. 50% of $1,000. Well, if you're going to go buy a thing for $1,000, let's say like a nice computer, like a gaming computer, and there's a 50% off sale, that means how much did that thing cost? Well, 50%, we should be thinking the word half, right? 50% means half of. So when you start to think about that, and of meaning kind of multiply, so it's half times 1,000. And you could actually do that on your calculator, right? But you probably did it intuitively. But on your calculator, you would put in 1 divided 2 times 1,000, and that is going to get you $500. So if you got a computer on sale that was normally 1,000, it was down 50%, it's now costing you $500. Don't forget those dollars. Units are always really, really important. This is different than like 1,000 pencils, and then you end up with 500 pencils. When we're dealing with money, let's stick with money. So that half, again, translates through there, and you can even do it on a calculator. Those questions will get harder over time, but you can start with your intuition around that. So that's question 4. Question 5. We're looking for perimeter. So there's 2 things here, right? Perimeter and area. I want to be sure that folks know the difference. Area is like if I draw a box, it's like how much do I need to color in that box. Perimeter, if I draw a box, it's like if I was a person and I was walking around that box, I'd have to walk to this corner, I'd have to walk to this corner, I'd have to walk to this corner, and then I'd have to walk to this corner. All those steps that I took, that whole distance I went outside the box, that's the perimeter. It's like the outside. And this area is like the inside. And the inside is like all this shaded region. So, just so we're starting with that, and we're going to talk about area and perimeter and the differences between them. This question's about perimeter. So I gave you a box. And I said, first of all, there's little hash marks there, that this is 5. Well, these hash marks in math language, because math is just a different kind of language, and we need to know the symbols. These little hash marks on the sides, well, those actually mean that they're all the same. So that means this is the same as this, which is the same as this, which is the same as this. So if this is 5, I know this is 5, I know this is 5, and I know this is 5. But math people are kind of lazy, so we try to write the least amount that we need to. So if I just write those little hash marks, you know those are all the same. So the perimeter, we go back to this idea, and this little person, right, walking along. If I got to walk 5 down here, 5 over here, 5 and 5, that's just 4 5s. So you could see how I could also do 4 times 5. But 4 5s all added up is 20. I didn't give you units on this on purpose. It could be 5 kilometers, could be 5 light years, which is like a space measurement. It could be 5 feet, could be 5 micrometers, all sorts of units. So the important part here is 20. That the perimeter of this box is 20. So that is question 5. Question 6. We're starting to get into fractions here. I'm actually going to do both question 6 and 7 right beside each other. So the first one is addition of fractions. Fractions can be scary, or at the very least annoying. Please don't be annoyed by them. You just got to learn some tricks, and you just got to memorize some stuff. It makes your life super easy. First off, 1/8 plus 3/8. When you have addition or subtraction of fractions, it's actually one of the harder questions that you had to learn in elementary school. First things first, you figure out if the bottoms are the same. So step 1 is, are the bottoms the same? If they are, then you don't need to do anything. That's why I'm giving you this question. The bottoms are the same. It makes your life easy. Next step is you add or subtract the tops. And so it is just that simple. The bottoms actually stay the same. So that number, if it's the same here, it's the same here, it's going to be the same in the answer, which is kind of weird to think about, but that 8 doesn't change across the bottom because they're the same in these. First, and then the only thing that we really need to do is add the top. So we've got 1 plus 3 is 4. So the answer here is 4/8 when we add, because the bottoms didn't change. The tops were the only thing we had to add. That's 4/8. You could have simplified that to 1/2. We'll get to simplification later, but that would just be a fine answer. But just as a note, if you simplified it in elementary school, you're taught to simplify it all the time. As you get older, you realize that might actually be not a good idea, like say in university. So they tend not to simplify things as you get older. It's a good skill to have, but it's starting to become not necessary as you're getting older here. So don't worry about it. Question 7 is the same thing except times in the middle. Now, what do we do here? Well, this is different, and I'm showing you these on the same sheet so that you can see them back to back. These are different questions. Plus and minus is treated like that. You have to do the bottom is the same, and then you add the tops. Down here, it's much easier. If you get addition or multiplication or division questions, you just basically connect the tops and the bottoms. The tops straight across. 1 times 3 is 3. 3 times 1, right? 1 times anything is just itself, 3. Over top, 8 times 8. Well, we know that's 64. You could do that on your calculator, right? Anybody can use their calculator. You can use it on your computer. You can use it on your phone. You know, you're going to have a calculator for the rest of your life, and you should be able to do these questions with them. So if you need that, that's totally okay. So the answer to this, because we did the tops and then we did the bottoms, the tops made that number, the bottoms made that number. The answer to that one is 3/64. So you can see how addition and subtraction of fractions is different than multiplication. We're going to come back to this a lot. You're going to practice this a lot until it's just second nature. So that is question 6 and 7. And again, because this is a video, if you didn't get that quite, or you fell asleep or got distracted, somebody called you, just rewind the video, rewatch a part, and so that'll help you understand. Question 8. We got 5 with this little 2 up there. So we went through this in class, but this thing is an exponent. You might have heard of these before. You might have heard of BEDMAS. That's a math thing. It's an order of operations. The E stands for exponents. But for right now, forget about that and just focus on the exponent part. Exponents, what those do is they tell you how many times to multiply a number by itself. Now, that might sound kind of weird. How many times to multiply a number by itself? So I'm going to take this 2, and so if this 2 is telling me how many times to multiply a number by itself, well, this is the number. So I'm taking 5, and I'm just going to multiply 5 by itself, and I'm going to put that twice, or 2 times. So here's once, here's twice. Well, that is 5 to the 2, we say, or 5 squared. 5 times 5, that equals 25. And it's as simple as that. Let's just show another example. If I was to give you 5 to the 3rd, well then I would just have to go 5 times 5 times 5, and that would be 125 is the answer. But in this case, we have 5 squared, which we don't have that last 5, so it's just 5 times 5, and it is only 25. So those are exponents. You're going to use those a lot this year. It's good to start to get comfortable with it, right? This is not 5 times 2 equals 10. It is not that at all, right? Exponents are a different thing. They just multiply the thing by itself. So really want to drive that into your brain there. That was question 8. Question 9. Question 9 is 10 equals x over 2. So x equals what? You probably have a gut reaction to this. I don't need to tell you that x is actually 20. Now, maybe you didn't have a gut reaction. Well, the way that you think about this is, okay, 10's over here, 10 equals, well, something divided by 2. So if I told you I had some amount of money in my pocket, and then I gave away half of it, I took away half, and then I was left with 10 bucks. So I had some amount, I gave away half, now I have 10 bucks. I'm sure when I reframe that and put that in English, you can think intuitively, okay, well, I started with 20, I gave away half, which is 10, and then I'm left with 10. Okay, that makes sense. So you can do this intuitively, but the math we use here is actually to multiply both sides of an equal sign by the same thing. So if I have 10 equals x over 2, I can multiply this by 2 over 1. But if I do anything to one side of an equal sign, on this side, I need to do the exact same thing over here. So I need to multiply 10 by 2 over 1. So over here, well, what happens is those 2's cancel. That's why I chose this 2. Right? This 2 didn't like magically appear. I chose it on purpose to get rid of this 2. Now that those are gone, this 1 really doesn't mean anything. Anything over 1 is irrelevant. So we've got x. So I just I changed this side into x. And then, well, 2 over 1 here, well, the important part is 10 times 2, which is going to be 20. So when I did this algebra and I multiplied both sides by 2, I canceled out the bottom 2 and I added a 2 and I made this into 20. This is the foundation of algebra. So algebra is this thing where you move equations around, right? You solve for x. You've seen a lot of these. You've probably done a lot of these in your past. They can get really annoying. The reason why we do this is we learn basic rules. This is kind of like math grammar, right? If I do something over here, I need to do it here. When you become fluent in this language, you can solve much more complicated problems. Just like when you become fluent in English, you can read harder books. In math, you can do harder problems when you become more fluent in this. So that's why we're practicing this. This is one of the sort of hardest, most basic ideas. You have a variable divided by some number equals this. How do I get this variable alone? How do I get this x alone? Because we don't know that. And the way that you do that is you multiply both sides by the same thing. So that's question 9. X equals 20 there. That should be the answer that you get. And then question 10. So you can go online and you can solve these. There's also apps that you can get for your calculator for these. I have a few recommendations. If you want to, let me know. But otherwise, this is starting to get into graphing. This is an equation. And I'll draw the picture, which is this. This equation goes with this picture, just in the way that if I write the word dog and I showed you some picture of a dog, tongue hanging out. This is a dog-like camel creature. Then this picture and this mean the same thing. This equation and this picture mean the same thing. You're used to seeing this. You're not used to seeing that. That's why you need to start practicing. And I'll give you a sense of how I did this. So remember, this is the x-axis and this is the y-axis. If x is 1, y is 1, and that meets right there. If x is 5 and y is 5, that meets right there. When we plug in values and we say x and y, this is a t-chart. This is the best way to solve these. When you say x equals 0, well, y equals 0, right? When x equals 1, y equals 1. When x equals negative 10, y equals negative 10. When x equals 100, y equals 100. We could keep writing that, but that gives us enough points on this line to be able to draw it. So y equals x is this graph, and then we're going to talk about how to move or transform this graph around. For example, if I put plus 1 here, well, that gets a little bit trickier. And so how does that happen? Well, it turns out this plus 1 actually just shifts everything up slightly. If you want a challenge, you can think about why that's the case, how to graph this, how to mess around with this x, and what that does to y. That's where we're going with this math over time. But for now, just focus on that first graph, y equals x. Going through that point 0, 0 right at the middle, and then just going up to the top right and down to the bottom left. Hope that this helps. Again, we're going to mark every day and give yourself a mark out of 10 for today. How'd you do? And I'm also going to look at your sheets to see how you're doing and how you're thinking and how you're progressing, and I hope it's doing well. Today we will not have the financial math piece or the other or Khan Academy, but if you do get bored and want to go ahead, feel free to sign up to Khan Academy and then start working through. Everybody's been assigned work who's in my class. And the way that you do that is there's a post earlier with the code in it. So I hope this has been helpful. Thanks very much, and let's call it a day.